how are you doing then?
Yeah, I'm trying to do things that get my mind off it, like maths.
Yeah, I went for a jog earlier.
Yeah, how did that go?
Didn't take my mind off him, tripped up on the curb, grazed my knee.
See, Harry blended that right up, he would.
He would have, maybe even worse, I guess.
Yeah, that's very upsetting. I really miss him, you know, this shell, the way he stole our cookies, replaced it with lettuce.
The drinks he made, the jokes he made.
I made us laugh, and his pictures were great.
Yeah, we should do pictures
Well,
sometime,
yeah,
just
yeah.
in memory of him.
Yeah, because he took pictures of his holiday and stuff in Africa. Can't go to Africa though.
No.
I mean, this is Harry, God rest his soul, he died of snail Ebola, and that's spread to people now.
I've heard the same thing. Where should we go then?
Oh, the Erdai Wang system.
Oh, China, that was good.
Yeah, we're going to China. Alright, we're going to China.
Okay.
And we need to replace him at some point, won't
Yeah, have you had any interviews?
I had a few interviews. I interviewed a couple of snails, a snake. One that didn't do well.
Did you not?
But it's okay, we'll find him. We'll find one.
Okay, shall we just, what if we get on with maths, but as a duo it might just cheer you up.
You might, yeah, okay, so what are we on to?
Something different.
Differentiation?
Yes, no, we're taking a method.
Ah, but not yet.
Not yet.
Oh, yeah.
Oh, not yet.
Alright. So, we did this in core 2 though, didn't we? And
Yeah.
Core 1 and all of it.
And we'll probably do it again in core 4.
Oh, look forward to that.
But massive steps up now, unfortunately.
It's disgusting, actually.
It is.
It's probably one of the worst topics in core 3.
So we're going to start off with just some simple rules you need to know.
Yeah.
So, differentiating certain things.
And these certain things have recently gone through, like e to the x.
Yeah.
So let's start with that.
So, you've got e to the x. The derivative, I'm just going to call it d,
Alright.
of e to the x.
Is, well, it's e to the x.
It is indeed.
Yeah.
E to the x. Just like that.
Just like that, which makes tons of sense.
If it was e to the 3x, then the derivative would be
3 e to the 3x.
3x.
Yeah.
Just like that. So you don't reduce that like you would normally in differentiation when you times the coefficient. It would just be that.
Yeah.
And that's the derivative of e to the x, that's new.
Yeah, another one is ln of x. So
Yeah.
just head that as well.
d of ln of x. Now that isn't quite simply ln of
No,
x.
it isn't. That is 1 over x.
It is indeed 1 over x.
So what are the other ones you need to know, Wayne?
Well, we need to know our sine, cos and tan if we
right.
differentiate them.
So, how do we differentiate sine?
Well, let's see now.
Okay.
d of sine x is cos x.
Yeah.
And that's that.
That's that. These are the things you just have to know. You can show why they are these things, but we're not going to.
Cos x, do you want to hazard a guess at what that might be?
Is it sine x?
Not quite.
Tan x?
Oh, not quite.
Harry x? I'm sorry, it's just on my mind.
Oh no, get him out of your mind, get him out of your mind, I'll tell you the answer.
Okay.
It's negative sine x.
Oh, alright.
Just cos it is.
Huh.
Yeah, you get it.
Yeah, that's good. Right. And finally we have the differential of tan x,
Yeah.
which is sec squared x.
Just one of those things you have to remember. Again, there is a proof. The proof on this one relies on the fact that tan x is equal to sine x over cos x.
Mhm.
Differentiate each of these with a quotient rule, which
Which
we're going
we
to get onto.
We are, but if you do that, then you'll get that as a final result. So we have all of these, and as Wayne mentioned, one of our rules, we've got a quotient rule, but first we've got the product rule, so I think we should kind of go on to that
I
next.
think we should indeed. Let's go.
Alright. Rule number 1.
Yes, it's the product rule. It is rule 1 of 3, in fact.
Here's rule 1 of 3, so without further ado, it's the product rule because it's two things times together. So,
Yep.
got an example, Wayne?
Yep.
Alright,
Yep.
yep. So what have we got?
Y equals x to the half e to the x.
Alright, so these things, if you times together, you get a product, so you use the product rule.
Because you can't differentiate that as it stands. So, and then the product rule always applies when it's y equals u v.
And the U and V are very important at the moment.
Yes, they are. They come up a lot in every single rule.
Hooray!
So, u and the v just means there's two things times together, which is a product. In this case, it's a half, x to the half and e to the x is one's u, one's v.
So, the steps you do on the equation, with every part of that, you have a useful equation. You use u and v, so what you have, the differential, is u lots of dv by dx and v plus v lots of du by dx.
That would be your formula. But we're not going to do this example. I've got, I think you found another one, didn't you, Trev?
I did find another one, and it's over there.
Ah. So I'm going to rub off this, but keep the rule up, and we're going to go through a different example.
Here it is.
Okay.
And if I just managed to fight a dragon to get this way. It's crazy.
Did you?
Yeah.
Did you? So you won. Is it dead, or did you just?
No, I just legged it.
Right.
Okay. I fought, had an argument, took a book and ran. Similar, right?
Pretty much.
I think that's what
You can make a
Bilbo did.
movie on that.
Yeah, they did. Hobbit, right, okay. So, part A is find the exact values of the coordinates of the stationary points of the graph, that's the important bit, y equals x squared e to the x.
Y equals x squared e to the x. Shall we just do this question before we read the next one, or shall we?
I think we should. So it says find the stationary points. To do this, we need to differentiate to find the gradient.
And to differentiate, we're going to need the product rule, because you can't just differentiate this. If you look at it, try it, you'll die.
Yes, absolutely.
Y equals uv, you'll notice u and v, you've got two different things.
Yeah, it doesn't matter what order you do it in, but you should choose it and then be consistent with it.
Yes.
So u could be x squared and v could be e to the x.
I think we'll do that.
Yeah.
And then from this point in, you have to stick with it. So du by dx is the next step. Is differentiating just this
X squared, which should just be 2x, and we do the same for the other half. I mean, one of the things you just have to know when you differentiate e to the x, it just becomes e to the x.
Yes, so now we can go ahead and apply this formula, because we have all four
Absolutely.
aspects.
And this is a nice way to set it out, it's very easy to follow in your exam. So we x squared lots of, that's our u, r e to the x, plus the other half, which is e to the x lots of 2x. Doesn't really matter how you write it, but we write it a bit nicer, because we don't want to just find this, we want to find the stationary points.
To find the stationary point, you've got to make it equal to 0. Then you're going to have to factorise it, because that would be a nightmare to leave in that form
It
and
would
find
be
the coordinates.
A nightmare,
That
so
would be trial and improvement to the max, that would be.
max, since we're not Pepsi, we're just going to factorise it.
Okay, so to find the stationary values, you've got to make it equal to 0.
Yeah,
So
the gradient is 0.
we can take out a factor of e to the x
We
to
can.
start with. So you've got e to the x lots of x squared plus 2x.
We
That
have
would be
got that.
a factorisation.
Mm-hmm.
But that's still a bit ugly.
Yeah,
We can take it a step further by factorising this again.
yeah, the centre bit.
So we can have x lots of x plus 2 will be the factorisation of that.
Yeah, and then around that we have e to the x.
Yep, which we can just represent by putting it here.
We could do that.
And do that. And that's now equal to 0. From this stage you can now find two values. What would they be, Trev?
Well, there'd be x is minus 2, so that way that part will equal 0. Or when x is equal to 0.
The e to the x you can just leave well alone.
You can leave it alone because e to the x will never equal 0 as it never reaches it.
So at this stage you can just leave it.
Yeah.
So x equals minus 2 and x equals 0 is your two x coordinates. We now need y coordinates for it to be coordinates.
Yes. So you put it back into the original equation.
So if you put minus 2 into this, you're going to have minus 2 squared
Mm-hmm.
times e to the minus 2, which we can just leave as for e to the minus 2,
Yeah.
because e to the minus 2 would be a bizarre number.
You could write it down,
write
but it's
it out.
more precise to write it like that. I use inserts.
Yeah, because this goes on infinitely. So,
And then 0 times anything is 0.
yeah, so that's just 0, and that would be to the 1 to make it 0 overall.
Yeah.
So, as coordinates, you've got minus 2 for e to the minus 2,
And 0, 0.
0, 0.
So that'd be the stationary point. But the question, it doesn't finish there. The next part says, just turn the page, but I remember it, so it's okay. Find whether these points are maximum or minimum. So you remember from core 2 and core 1, should core 1?
Yes,
Yeah,
yes, you
yeah,
do.
yeah, yeah. You just have to differentiate it again.
Yes, which means using the product rule again now. So we're going to have this, e to the x times that,
Mm-hmm.
and then it's a product of two things. This one will be a product of three things, which
We
is too
can't
much.
do that.
But
We
we
can't
can
do
use
the top
this.
one because it's adding. So we can do that. So e to the x could be our u.
We'll swap places.
We can swap places.
Can I use your purple?
You can use, yes. It's a very special pen. Only Eddings have the purple. It's very
I
exciting.
very much love purple.
And Wayne's handwriting is a bit better than mine.
Y equals, I'm not sure about that, e to the x lots of x squared plus 2x.
So you want to find what this from this stage a dy to the x would be.
Yeah, so that's dy by dx.
Yeah, so essentially we're getting dy is squared over dx, d squared x. Is that right? No, it's yeah.
X squared, I think.
Yeah.
So this is going to be a product rule. The u is now going to equal e to the x.
Yeah, and then your v will be equal to x squared plus 2x.
Because they are the things multiplied together.
So then you want to find your du by dx, which again will be just e to the x. The second one won't be, it will be 2x plus 2.
Yep, I get that too.
Excellent.
So then we're going to times that by that and that times that, tossing them together as we do it.
Absolutely. So we have, yeah, e to the x of 2x plus 2, and then e to the x, I guess, or you do it the other way around.
Yeah, I'll do it the other way around, but I'll never.
Sure, but like that.
Like that. We can then
Right.
expand that out if we wanted to. I don't think we need to at this
I
point.
don't think we need to. What we need to do is put in our two values and see if they're a maximum or minimum.
Yep. So every x value first is going to be minus 2.
Minus 2 works, so e to the minus 2.
Lots of
Um,
minus 2
yeah.
plus 4 minus 4 is 0.
Alright.
Times e to the minus 2, is that right? 4 minus 4.
Yeah, that's time that will disappear, so it will just become
So it's just going to be
minus 2 lots of e to the minus 2.
which is going to be negative.
Yeah.
This is going to be less than 0, which implies
It's a maximum. Absolutely. Then our other one, which is when it's equal to 0,
Okay.
it will be,
So it's going to be e to the 0,
which will
is
be 1.
times 2. So
Yeah.
it's going to become 2.
Cool.
Plus,
2
That's
plus
e to the 1.
0.
0, so
plus-
it's just times 1, which is nothing.
So it becomes 2, which is positive, so it must be a minimum, as it's greater than 0. Ta-da! So it's a bit of core 2 and core 1 differentiation and a bit of bonkers product rule. Another product rule, there's another rule. Rule
Let's go to
number
that.
2. Peace.